Hello. In this session I'm going to discuss why we balance equations and actually how to balance equations. So when you're looking at a chemical equation, you have to make sure that it's balanced, and the question becomes why. Well, the answer is the law of conservation of matter. And the law of conservation of matter essentially says matter cannot be created nor destroyed. Now you can rearrange it, you can reassemble it, you can recycle it, but you can't destroy it utterly, and you cannot create it from nothing. So when you're balancing equations, it's very important to make sure that your reactants are going to equal your products. Now, does that mean the number of reactants equal the products? No, it doesn't. Instead, we're talking about the mass of the reactants equals the mass of the products, and another way to look at it is your number of molecules or atoms would need to equal out. So if you begin the reaction with 3 molecules of oxygen on the left and you think you've balanced it out, that means on the product side you would need to have 3 molecules of oxygen on the product side. And remember that when you're looking at a reaction, you have reactants added together, and then the reaction happens with that little arrow, and that gives you the product. So on the right hand side of the equation is where your products are. If you're to take an example like the one you see there, you've got sodium added to diatomic chlorine and it yields a molecule of sodium chloride. The first thing that you're going to have to do is step 1 is what I call the atom inventory. And basically what I do is I go and I separate my reactants from my products, and then I list them. So I have sodium and I have chlorine, and I have sodium and I have chlorine. So I know what elements I have to figure out my numbers. Well, sodium doesn't have anything down here, so that means I just have 1. Chlorine, on the other hand, has a subscript of 2, so that means I have 2 atoms of chlorine. On the product side, I have 1 atom of sodium and 1 atom of chlorine. Law of conservation of matter says you can't create or destroy matter. So the only places that you can add a number are at the coefficient spots that I just made into boxes. Well, your sodium and your sodium, they're each at 1, which, well, they're happy. But chlorine, on the other hand, chlorine goes from 2 to 1, and the law of conservation of matter says that that can't happen. So in balancing equations, you can only use multiplication. So in order to go from 2 to 1, I need to multiply the chlorine on the right by 2. And how I do that is I'm going to put a coefficient of 2 out in front of that sodium chloride. Now, just like in math, it's going to distribute. It's going to distribute to my sodium, which changes my sodium from 1. Now it's going to go to 2 because 2 times 1 is 2. And then the same thing for chlorine, though, which is what you're trying to do. 2 times 1 is 2. So now my chlorine is okay, but I've messed up my sodium, and that's kind of the way things work with balancing. You make a step and it normally messes something else up. But I can go through and easily fix the sodium. So now I'm looking at my sodium and it's going from 1 to 2, and I can't create matter, so I have to fix that. And I can fix it by putting a 2 there, because 2 times 1 is 2. Now I check it. My 2's match, my 2's match. Everybody's happy, it's balanced. Now there are some of you that will not be able to take the fact that that box in front of the Cl2 is empty. And if you are one of those people, you put a 1. So it's balanced with a 2, 1, 2. On this particular reaction or example, you've got iron that reacts with aluminum oxide, and it yields aluminum and iron 3 oxide. Same thing, you go through and you have to do an inventory. So you have iron, you have aluminum, and you have oxygen. Now, even though the elements don't show up on this in the same order on the right or on the product side, I'm still going to list them in that order. That way, visually, it keeps everything straight. On the reactant side, I have 1 iron, I have 2 aluminum, and I have 3 oxygen. On the product side, I have 2 iron, 1 aluminum, and 3 oxygen. In general, if you can balance your oxygens first in general reactions, it makes life a lot easier. But in this case, your oxygens are the same, so you really don't need to do anything to it. So we're going to go ahead and look at iron, Fe. It went from 1 to 2. Well, it can't happen that way. And iron just so happens to be out by itself over on the left-hand side. So you're going to put a 2 in front of iron. 2 times 1 gives you 2. It's 2 on each side. We're happy there. The aluminum, on the other hand, goes from 2 down to 1, and we can't have that either. But since it's by itself on that product side, I can put a 2 easily there, because 2 times 1 is 2. And now your aluminums are balanced, as are your oxygens. So it's balanced with a 2-1, 2-1. This last example is the creation of ammonia. So in this reaction, I have diatomic nitrogen added to diatomic hydrogen, and it yields nitrogen trihydride or ammonia. So I have nitrogen and I have hydrogen, again nitrogen and hydrogen, and again I'm just doing my atom inventory. On my reactant side, I have 2 nitrogen and 2 hydrogen. On my product side, I have 1 nitrogen and 3 hydrogen. So I'm going to go ahead and try and balance my hydrogens first, because it seems like that might mess up the most stuff. Now, on my left, I've got 2 hydrogen, and on my right, I've got 3. And I'm dealing with multiplication, so basically what I need to do is find the lowest common multiple. So if I multiply my 2 and my 3 together, I'm going to get a 6. So what I'm going to try and do is on the right hand side, I'm going to try and put a number out in front of the NH3 that'll give me 6 hydrogen. The only thing that'll do that is a 2. So I'm going to put a 2 there, and it's going to change my nitrogen to 2, because 2 times 1 is 2. But then I'm going to distribute it to the 3 hydrogen, and it's going to change it, and instead now I'm going to have 2 times 3, which gives me 6. Alright, so I'm seemingly halfway there. I look at my nitrogens, and they're 2 on each side. So I'm happy with that. I can put a 1 out there. And then I need to get an overall number of 6 hydrogens. I already have 2 there, so 6 divided by 2 would be 3. I put a 3 out there, and the equation is balanced with a 1, 3, 2. I hope this has been helpful, and I will add another recording soon of maybe some more practice problems. Thanks.